Hello guys, this is Dave. Today we are going to solve some questions on mechanics and whatever I have taught in my previous videos, okay? Alright, so this is the first question. It is written that a motor car is going due north at a speed of 50 kilometers per hour. Read the statement very carefully. It is going due north, okay? It makes a 90-degree left turn. Without changing the speed, I want to find out the change in velocity of the car, okay? So this is the figure. This is north, south, west and east, okay? So a car is moving due north at a speed of 50 kilometers per hour. Alright. Now it takes a left turn at a 90 degrees. This means it is now going west, okay? And its speed is unchanged. This means the speed is now 50 kilometers per hour again. I want to find out the change in velocity. First of all, it is written change in velocity, not change in speed, okay? So change in speed was 0. So you see initial velocity 50 j. If I mark this axis as j and this as positive I, this means this is negative I, right? Final velocity would be equal to minus 50 I. Change in velocity I want to find out. Change in velocity is velocity final minus velocity initial. So this would be minus 50 I minus 50 j. This would be the change in velocity. Change in velocity would be minus 50 I plus j. Now I want to find out the magnitude of this mod of delta V. This would be minus 50 times mod of I plus j, right? This would be root 2 because this is under root 1 square plus 1 square is root 2 equal to minus 50 into root 2. So this would be minus gets cancelled because it is magnitude, so 70, alright. So the magnitude of change in velocity is 70, right? So you see, and in which direction is this? So you see the direction will be given by this. Since both the coordinates here are negative, this means the direction would be in the third quadrant because first quadrant both are positive, second only x is negative, in third both are negative and in fourth only y is negative. So in this quadrant we have, since these are equal coordinates, you see 50-50s, so they are equal, hence the direction will be perfectly northwest. Alright, so answer is the magnitude of change in velocity is 70 km per hour northwest. Alright, so here C is answer 70 km per hour towards northwest, okay? Alright, so let's move on to the next question. This question is of the graph. It is written displacement time graph, okay? Read carefully. This is displacement, not distance. And when displacement comes into play, velocity will come into play, okay? If it had been a distance time graph, then speed would have come into play, okay? So we have to analyze these graphs and choose accordingly. And the four options are given. First is the particle is continuously going positive x direction. Second option is the particle is at rest. Third is the velocity increases up to a time t0 and then becomes constant. And fourth option is the particle moves at a constant velocity up to a time t0 and then stops, okay? So this is the displacement time graph given. I have to analyze the velocity. Since this is displacement, the velocity will be dx over dt, right? Velocity is the displacement upon time, right? So here at time t0, if this is O, then we see that this line has a fixed slope. Since this is the angle alpha, if I tend to take tan alpha, if this point is x0, then this will be x0 divided by t0, right? And this tan alpha will be constant, okay, because the slope of line is not changing. Similarly, the dx by dt will be tan alpha over here. Velocity is the slope of displacement time graph. You see, velocity is slope of displacement time graph. So here the slope is x0 by t0. Hence velocity is constant up to a point t0. Okay. Afterwards, this is a straight line. Okay. Hence the x coordinate is x0 and it's constant. So we have to differentiate with respect to time x. Since x is constant, this would be 0. So velocity is 0 after time t0. Hence v is constant till t0 and then 0. This means particle is moving till t0 and then stops. Okay. So here option D is the answer. The particle moves at a constant velocity up to a time t0 and then stops. Alright, so we have the next question. A person traveling on a straight line moves with a uniform velocity v1 for some time and then uniform velocity v2 for the next equal time. You see, velocities are uniform over here. Okay, velocities are uniform, means it is constant. Now I want to find out the average velocity for the whole time. Okay, this is the situation. Particle starts from A, travels for a time t till p with the velocity v1, and then after p it travels with the velocity v2 till b for a time t. These are equal times. Okay, I want to find out the average velocity. So average velocity is total displacement upon total time. Okay, let this displacement, this be x1 and this be x2. So x1 plus x2 upon total time is 2t. Okay, so what is x1? x1 is v1 times t, x2 is v2 times t. Okay, so what is x1 plus x2? x1 plus x2 would be equal to v1 plus v2 times t. So x1 plus x2 by t, this would be equal to v1 plus v2, hence we divide by half, so we get this. This is the average velocity. v1 plus v2 over 2 is the answer. Okay, so here option A is the answer, v equal to v1 plus v2 by 2. Alright, so the next question is, a person traveling on a straight line moves with a uniform velocity v1 for a distance x and uniform velocity v2 for the next equal distance. Now I want to find out the average velocity. This is different from the last question because equal time was given. Now here equal distance is given. Okay. Alright, so this is the situation. From A to P, it travels with velocity v1 for a distance x. After P, it also travels with the velocity v2 for equal distance. So the total displacement by total time, this will be the average velocity. Okay, because we are talking about velocity here. Since vector is same, velocity speed can be equated, so displacement and distance can be equated. So this would be 2x upon total time t. Alright, what is total time t? T would be t1 plus t2. What is t1? T1 is x upon v1, t2 is x upon v2. This would be total time t, and t is twice x upon v average. Okay, so x gets cancelled over here. So we have 2 upon v average equal to 1 upon v1 plus 1 upon v2. We can also write this as v average equal to twice v1 v2 upon v1 plus v2. This is the answer. Okay, whatever, both are the answers. Okay, so here answer is C. Okay, 2 upon v equal to 1 upon v1 plus 1 upon v2. Now this is a very interesting question. In a projectile motion, the velocity, first option is always perpendicular to the acceleration. Second is never perpendicular. Third is perpendicular to the acceleration for 1 instant, and fourth is perpendicular to the acceleration for 2 instants. Now how will we solve this? Okay, so this is the figure. This is the projectile thrown at a velocity v at an angle theta. Okay, the only acceleration here is due to gravity. There is no air resistance, no nothing. Okay, because in a purely projectile motion, when thrown from the surface of the earth, the only acceleration is g. Now I want to find out when these two are perpendicular. You see, in the first case at the origin, these are not perpendicular, we can see it. So we cannot just do this by guessing. Okay, we have to derive this. Now how do we find out? First, you see, v and g both are vectors, and when are two vectors perpendicular? When their dot product is 0. Okay, so this is what we have to do. For example, for any point of time, v vector would be, this would be the horizontal component v cos theta, and this would be the vertical component v sin theta, and this would be gt, right? So minus gt. Okay, this would be the vertical and this would be the horizontal component. So v would be v cos theta I plus v sin theta minus gtj. I have written minus gt because velocity is not constant in the y direction. Only in the x direction it is constant. In the y direction, gravity is acting to oppose the velocity. So there will be a decrease of velocity in a specific time interval t. So I have accommodated that. And what would be the g vector? G would be minus gj. Okay. If I assume this as positive I and the upward direction as positive j, this would be the negative j. Okay. So now I take the dot product of two vectors v dot g. What would v dot g be? You see, j dot I would be 0 automatically. J dot j would be 1, right? So this would be minus g v sine theta minus gt. This would be equal to 0. So this turns out to be t equal to v sine theta by g. At this point of time, the velocity and the acceleration would be perpendicular. Okay. So what is this time? You see, the y displacement, as I told you earlier, was v sine theta t minus half gt square. Okay. Since this projectile is going up and then coming down, there is a maxima achieved. Okay. You can derive this as well, by doing d square y by dt square. First, you have to do dy by dt to be 0 and then this to be less than 0. This will automatically be less than 0 because the curve is just like that. So there will be a maximum point. Okay. So when is that maximum achieved? When dy by dt is 0. So we just differentiate this expression. We get v sine theta minus gt to be 0. So this is similar to this. And hence t is this, v sine theta by g. Hence the velocity vector and the acceleration vector are perpendicular only at the maximum. And since this curve only has one maximum, so there is only one instant. There is only one instance where the two vectors are perpendicular, and this instance is at time t equal to v sine theta by g. So here C is the answer. It is perpendicular to the acceleration for one instant only. That is the maximum point. Okay. Alright. So this is a equation, this is a question of integration. I just wanted to take this question to clear our concepts. It is given that the velocity and displacement x of a particle executing SHM are related as v dv by dx equal to minus omega square x. It is given that at x equal to 0, v equal to v0, find the velocity v when displacement becomes x. Alright, so this is the equation v dv by dx equal to minus omega square x. Okay. Well, this is a typical equation for simple harmonic motion. Alright. So, now I want to find out the velocity as a function of x. Okay, so we have v dv, we take dx over this side, so we have minus omega square x dx. Okay, so we integrate this. Now when x is 0, velocity is v0. When x becomes x, then velocity becomes v. This is the velocity we have to find out. This is the question mark we have to find, because this is given, v0 is given. So we have v dv is v square by 2. Okay, limits are v0 to v, and this is minus omega square x square by 2. Limits are from 0 to x. 2 gets cancelled out. We have v square minus v0 square equal to minus omega square x square minus 0. Okay, so v is root under v0 square minus omega square x square. Alright, this is the answer. This is the answer for v. Okay, now this is the expression for velocity. Now I wish to plot velocity and x. Normally in SHM we plot x and t, v and t, a and t. I want to plot v and x. How do I do that? First of all, we need to understand that in SHM there is a mean point, mean position, okay, from which the particle oscillates. First is goes to the extreme position, let us say A, comes back and goes to the another extreme position, let us say B, and then comes back. Okay, so it is confined. Particle is confined between A and B. Okay, so if we see here very closely that when it comes to A and then goes back, it stops for a momentary time and then turns back. This means velocity at A should be 0. Okay, and then again at the other extreme it stops and turns back, so velocity at B should be 0. Alright, since it is SHM, both the points are equal distance, so let us say this is A and this is A. Okay, so when is velocity 0? If v is 0, then v0 square would be equal to omega square x square. Okay, right. So this means x equal to plus minus v0 by omega, or we can say this is A. Alright, so at this point velocity is 0. Okay, this we have established. Now when is when x is 0, what is the velocity? Velocity would be plus minus v naught. Since this goes out and root under v naught square is plus minus v naught. Now I want to know what is the curve. So you see, this is very simple. We don't need to do differentiation and all that. We can just square it up. We see v square equal to v naught square minus omega square x square. We bring omega x whole square to this side. So we have v square plus omega square x square to be equal to v naught square. We just divide the expression by v naught square. We have v upon v naught whole square plus x divided by v naught by omega. Okay, whole square, this square and this square, okay, to be 1. This is the equation for ellipse. Alright, so I have a simple understanding that curve between v and x is ellipse. Alright, so what kind of ellipse? You see, this is an ellipse. Alright, this would be v and this would be x. At this is a point A, this is positive v naught by omega, and this is point B, this is negative v naught by omega. V naught by omega I have called A, and this is one point where velocity is positive v naught and this is negative v naught. Okay, this is the answer. This is the curve and it is ellipse. Alright, so let's take another question. It is given that the particle moves along the x-axis as x equal to u times t minus 2s plus a times t minus 2s, okay, whole square. Okay, this I think s is second, okay, so t minus 2 we can say. So we have to choose the correct option. First is initial velocity of the particle is u, second the acceleration is a, third acceleration of particle is 2a, and fourth at t equal to 2 particle is at origin. Okay, so we see the position of particle is given as this. Okay, so particle is moving along the x-axis in according to this equation. So we have to find out the initial velocity, acceleration, and where the particle is at t equal to 2. Okay, this x is not the displacement, this is the position with respect to origin. Okay, so this means what is initial velocity? Initial velocity would be at t equal to 0, right? First of all, you have to calculate velocity. This would be dx by dt. Okay, so this would be u times 1 plus 2a times t minus 2, right? This would be the velocity, equation of velocity, because we are differentiating x with respect to time. So u times 1 plus twice a times t minus 2 times 1, right? So at t equal to 0, this would be u minus 4a. This is the initial velocity, u minus 4a. Okay, now what is the acceleration? Now we double differentiate this, d square x by dt square, this equation. So we have, by double differentiating, t minus 2 would move out, t would be 1, right? So this would be 2a. So the acceleration is 2a. Okay, and at t equal to 2, if we put t equal to 2 here, the x reduces to 0. So this means at t equal to 2, the particle is at origin. Okay, so at t equal to 2, particle is at origin and acceleration is 2a. So the answer to this question is C, because in the option C, the acceleration of particle is 2a, and D also, because at t equal to 2, particle is at the origin. So answer is C and D both. Okay, now suppose let us say the velocity is not constant. Okay, it is varying, and the equation of velocity is this: v equal to v naught sin omega t. I have to find out the average velocity over the interval, for example 0 to pi. Alright, so in this kind of questions you cannot be discrete. For example, you add up small distances x1, x2, x3 and then divide by total time, because this is continuous function, this is not a discrete function. Sine is a continuous function. If we plot v versus omega t, this is obviously a continuous function like this. Alright, now if we are to find out the average velocity, it will be the total displacement by total time. Yes, this is the definition. V average is total displacement by total time. Okay, But what is the total displacement over here? Just cannot calculate it by normal method. Okay, you need calculus for this. So this is integration v dt. Since this is the area, alright, the area under vt graph is the displacement if v is velocity. Okay, the area under vt graph is displacement, and this displacement is positive if it is in the first quadrant, and it is negative if it is in the last quadrant, or we can say if the third quadrant. Okay, so for example, if this is pi, this is 0, and this is 2 pi. Now I want to find out the average velocity from 0 to pi. So what I do is I just integrate this from 0 to pi. So we have the displacement, and I divide it by total time taken. Alright, what will be the total time? Total time would be pi over omega. Okay, here total time would be pi. This is 0, then this is pi over omega. Sorry. Yeah. Okay, since we are plotting v versus omega t. Alright. So, sorry, v versus t we are plotting. Yeah. Now v versus t we are plotting. So, we have the time as pi by omega. So, this is the v average I want to obtain. Alright. So, we just integrate this v naught sine omega t dt by pi by omega. And this goes from 0 to pi over omega. Sin x dx. Sin x dx is minus cos x. Alright. Because, the differential of cos x, d by dx of cos x is minus sin x. So if I take dx over here, then integration sin x dx would become minus cos x. This means this would be minus v naught cos omega t by omega by pi over omega. And this goes from 0 to pi by omega, right? Omega gets cancelled out. So we have cos pi is minus 1, minus cos 0 is also minus 1, then minus 2. Minus gets cancelled, so we have 2 v naught by pi. This is the average velocity. Okay, from 0 to pi by omega, sorry. Okay, this is the average velocity from 0 to pi by omega. Now I want to find out the average velocity from 0 to 2 pi by omega. For this, the whole time period, this will actually turn out to be 0. You know why? Because this portion has the same area as this portion, and since we are talking about velocity, the upper portion will be positive, the lower will be negative, so these two will cancel out. So net displacement would be 0. Okay, obviously we can also see from this equation, you see, instead of 0 to pi by omega, if I take 0 to 2 pi by omega, then what happens is cos 2 pi is 1 minus cos 0 is 1. So 1 minus 1 is 0. So we get 0. Alright. So you can see how the velocity varies. And due to variation of velocity, average velocity will also vary. Alright. Alright, so this is the next question. The velocity time plot for a particle moving on a straight line is shown. This is the line. This is a straight line sloping downwards. And this is the VT graph. Okay. We have to choose the correct option. The particle has constant acceleration. The particle has never turned around. The particle has 0 displacement. And the average speed in the interval 0 to 10 is same as the average speed in the intervals 10 to 20. Okay. Alright, so this is the question. This is the VT graph. First of all, I want to find out how V varies with T. So we will find out the equation between V and T. Okay. Now in general, any equation is written as y equal to mx plus c. C is a constant. Okay. So this equation can be written as v equal to alpha t plus beta. And beta will be this. Alright, I'll show you how. Now what is alpha? Alpha is the slope. This is angle theta, but alpha is actually tan theta. Alright. This angle is also theta. Since line is sloping downward, slope will be negative. So alpha will be minus tan theta. What is tan theta? 10 by 10, which is 1. This means alpha is 1, minus 1. Here also we can see this is 20 and this is also 20. Tan theta is 20 by 20, which is 1. So alpha is minus 1. We have established this. So V would be equal to minus t plus beta. Alright. Now when V is 10, t is 0, this means beta would be equal to 10. Also when V is 0, t is 10. This means minus 10 plus beta is again 0. So beta is again 10. This means beta is 10. Okay. So V equal to minus t plus 10. Now, Now what is the velocity? This is the velocity, and now what is the acceleration? dv by dt, which is equal to -1, and this is constant. This means the first option is correct. The particle has a constant acceleration. Now next option. Particles never turn around. Well, you see the displacement in 0 to 10 would be positive because this is in the first quadrant. But here displacement in 10 to 30 would be negative because in the last quadrant. And you see at 10 velocity is 0. This means velocity will now turn around. The particle will now turn around and go back as acceleration is negative. So in 0 to 10, what is the displacement? This is the area. Area will be 50 of this triangle, and this triangle has an area of 400 by 2, which is 200. So what happens is the particle starts from O. This is a point A and this is point P. So particle starts from O, goes to A. This is 50. Now particle stops here, turns around and starts from A and goes to point P, which is over here. Okay. Alright. And this is 150. So total from A to P it is 200. Alright. The displacement I'm talking about. So particle has turned around, yes. And it has covered extra displacement of -150. So particle has never turned around is wrong. The particle has zero displacement is also wrong, because if it was zero displacement it would have reached O again, but it has traveled 150 more in the negative direction. Now average, actually it is speed in 0 to 10 is same as average speed in 10 to 20. Yes, because if we are counting speed, then I will not take the signs of this the signs of these areas. Alright, speed is total distance by total time. So from 0 to 10 total distance is 50 and total time is 10, so 5 average speed. And from 10 to 20 again the total, when it stops and when it turns around. So I will not see the direction now, I will only see the magnitude. So half into 10 into 10, because this is 10 and this is also 10. Alright, so half 10 10 would be also 50 again. So this means 50 by 10, because time interval is 10, so 5. So speed average would be 5. So this is correct. Alright, this option is correct and this option is correct. A and D are correct. Alright, because speed has been asked, so I will not take into account the sign. Alright, so guys, I am stopping here now. I will continue the series of questions so that you can have a clear understanding of concepts and you will be able to solve any question that comes in the exam. Okay, any MCQ that comes in the exam, I'll make you such that you can solve any question. Okay, please like, rate, review, subscribe. Okay, and I will continue this series of questions. Alright, I'll continue the video on the series of questions and I'll make more videos. Okay, thank you.